Let us take a look at a billiard table, something most of us are all familiar with. The balls are all stationary. What will make them move? A push from the stick, that is, an external force. The important thing to note here is that without this push, or an external force, the balls will remain at rest for an infinite duration. Thus, motion is a direct result of force. This relationship between force and motion was studied by Galileo and Newton. Galileo was the first to abstract from what he and everyone else saw. An object in a state of motion possesses an inertia that causes it to remain in that state of motion unless an external force acts on it. Sir Isaac Newton further studied Galileo's ideas on force and motion and presented three fundamental laws that govern the motion of objects. These three laws are known as Newton's laws of motion. In this lesson, you will learn about Newton's first law of motion and inertia. At the end of this lesson, you will be able to explain Newton's first law of motion, explain the concept of inertia, examine inertia based on object size. Newton's first law of motion states that an object will remain at rest or continue to move at a constant speed in a specified direction unless an external force acts upon it. This law relates force applied on a body to the change in its velocity. There are two aspects of this law that we need to consider. First, an object at rest will remain at rest unless an external force is applied to it. All objects at rest conform to this. For example, on a golf course, a ball or a tee remains at rest until the golfer hits it. When the ball is hit, a force is applied setting the ball in motion. The second aspect relates to a moving object. An object in motion will move at a constant speed and in a fixed direction, unless an external force is applied on it. Consider an artificial satellite revolving around the Earth. It moves with a constant speed and in a fixed orbit. The orbit of satellite will not change on its own. In case the satellite is required to change its orbit, booster rockets are fired up to exert force on the satellite. This changes the speed and direction of the satellite. You may have questions about the validity of this law. This is not how things really work around you, is it? For example, if a batsman strikes a ball, the ball eventually comes to a stop, no matter how forcefully the batsman hits it. This has been explained through the concept of friction. Friction is a hidden force that arises between two surfaces in contact. This force acts in a direction opposite to the direction of the force trying to move an object. Friction is used in our daily lives to slow down and stop moving objects. To put it simply, the essence of the first law of motion is that all objects resist a change in their state of rest or of uniform motion. For example, when you try pushing a boulder at rest, it resists motion initially. However, if you exert enough force, the boulder starts rolling. Consider another situation where a truck is carrying an unfastened load. When brakes are applied suddenly, the truck stops, but the load moves forward and hits the back of the cabin. This is because the load tries to retain its state of motion. This tendency of undistributed objects to stay at rest or to keep moving at a constant velocity is called inertia. You can see this concept when you play a game of caroms. If a fast-moving striker hits a vertical stack of coins, sometimes only the bottommost coin in the stack is pushed out. The rest of the coins in the stack remain intact. The stack of the remaining coins comes down vertically, retaining the position of rest. This is because no force was applied directly on them. Now let's look at an object that retains its state of motion. A satellite orbiting the Earth continues to revolve with constant velocity, as no external force such as friction is applied on it. In real life, on Earth, it is difficult to find an ideal frictionless surface. Let's analyze some more cases where we observe this law at work in our everyday life. Look at the standing passenger in this bus. The bus starts suddenly, and the passenger is pushed back. This happens because the lower part of the passenger's body, which is in contact with the bus, begins to move with the bus. However, the upper part of the body tends to maintain its state of rest. As a result, the upper body tends to fall backwards and the passenger experiences a jerk. Similarly, when the bus slows down by applying a sudden brake, a standing passenger tends to fall forward. This is because, at this time, the lower part of the body, which is in contact with the bus, tends to stop while the upper part of the body resists the change and tries to maintain its state of motion. Now that we know what inertia is, the next question is inertia equal for all objects? There isn't a yes or no answer to this question. Inertia is proportional to the mass of an object. This is evident when you try to push empty boxes versus boxes filled with packages. It is easier for you to push an empty box, right? Kicking a football around is fun. But would you try kicking large stones of the same size? No, that would hurt, as you can see. So, remember, the larger the mass of an object, the greater is the inertia. Based on this, if you compare a car and a train, and a plastic coin and a nickel coin, which of these would have more inertia? You would need to compare the mass of each set of objects. The mass of a train is more than the car, so the train will have more inertia. Similarly, the mass of a nickel coin is more than that of a plastic coin. Hence, the nickel coin will have more inertia. We are all advised to wear seat belts while driving. Why do you think it's so important? Let's find out. When the driver of a car applies brakes and the car slows down or comes to a halt, have you noticed that the driver's body tends to continue in the same motion due to inertia? Inertia is the reason the driver is pushed forward in such situations. The seat belt restrains the body and prevents this forward motion. By doing so, it protects the driver from injuries that may result on sudden braking at high speeds. In absence of seat belts, applying sudden brakes may cause the driver to hit the steering wheel or front panels of the car violently, resulting in an injury. As the first law of motion explains the concept of inertia, it is also known as the law of inertia. This brings us to the end of the lesson on the first law of motion. In this lesson, you have learned about Newton's first law of motion, inertia, and the link between mass and inertia. To revisit the key points covered in this lesson, please review the flashcard at the end of this lesson.